All right, Honors Geometry students, this is part 3 of your Honors Geometry summer packet, polynomials. Feel free to take notes or just watch to refresh your memory about these properties. The first rules we are going to talk about are the power rules. These power rules deal with multiplying and dividing numbers with like bases. First, we have to talk about what is a like base. So, for example, if I am multiplying 2 to the third times 2 squared, both of the large numbers are the same, those are the bases. When I multiply numbers with like bases, I am allowed to just add the powers together. So 2 to the third times 2 squared would be 2 to the fifth. It's the same with variables. If I have z to the fifth times z to the seventh, that would be z to the 12th. So whenever you multiply numbers with like bases, you will add the powers together. Division is similar. When you divide numbers with like bases, so for example, 3 to the 7th divided by 3 squared, you would end up with 3 to the 5th, because you just subtract the powers from each other. Similarly, if it was 3 squared divided by 3 to the 7th, you would end up with a fraction. You would subtract the powers, and you put your answer wherever the larger power would be. So 3 to the 5th would be in the bottom. It's the same with variables. If I had a to the 7th over a to the 6th, my answer would just be 7 minus 6, which is a to the 1st. This rule only works if your bases are the same. So if you have an x and a y, you can't combine x and y numbers together because they're not like terms. Let's look at a couple examples. In this first example, we have all x's. Notice that there's x to the third and x squared being multiplied on the top, and then that whole quantity is being divided by x to the fourth. So the first thing I would do would be to combine any variables that I can together. So x to the third times x squared is x to the fifth. X to the fifth divided by x to the fourth is just x to the first, or plain old x. The second example has x's and y's in the same problem. So if you notice, you can combine the x's by subtracting the powers. X divided by x squared, you would just have one x left, and that x would be in the bottom. For your y's, we have y to the fifth and y to the first, and we would also subtract the powers here because we have a division relationship. 5 minus 1 is 4. So your answer would be y to the fourth over x to the first, or just plain old x. Whenever you have a different relationship, such as adding or subtracting, you're only allowed to add or subtract variables that have the exact same variable. So for example, 3x squared minus 5x squared. You can say that this is 3 minus 5, which is 2, negative 2x squared. But what you can't do is if it was 3x squared minus 5x. You cannot subtract these two numbers because they are not being multiplied by the same thing. X squared is not the same as x. That's like saying 9 is the same as 3. So the only way to really simplify this is just to leave it like it is. So let's apply this to an example like this. A lot of times what I like to do is to try to match up my terms that are like. So I'm looking for anything that has an x to the third. So I have a 5x to the third and a 2x to the third. So I can combine those two together. Note that this negative sign is going to stay with this 5. Sometimes it helps if you write them on top of each other like this. So 2x cubed and minus 5x cubed. So those two are going to go together. Next, I'll deal with the 4x. I have a 5x, so I'll write that underneath my 4x. I also have a negative 3x. So I'll also write that underneath my 4x. And I'll kind of scratch those out so I don't mess with those again. And then this 2x squared, this negative 2x squared, doesn't really have anything to combine with. So I don't have to do anything with that. So now that I have my like terms all matched up, all I'm going to do is combine them. So 2x cubed minus 5x cubed. So that would be negative 3x cubed. And then I have 4 plus 5, which is 9, minus 3, which is 6. And then this negative 2x squared didn't have anything to combine with, so I'll bring it down. And typically, whenever we're dealing with a polynomial, we like to write them in descending order, meaning that the term with the largest power goes first, and then the term with the next largest power. So I'll write the square, and so on and so forth. So this would be my solution. Again, I am only allowed to combine numbers, meaning adding or subtracting them, if their variables are the exact same thing. We've already talked a little bit about the distributive property, but typically whenever we're multiplying polynomials, that is the property that we use. And there's a couple different ways to apply the distributive property. One is a situation like this, which we very commonly see. We have this 2x is being multiplied by the quantity 3x plus 4, and the negative 7x is on the outside. So before I can do anything, I want to distribute. So if I have 2x times 3x, I can multiply the 2 and 3 together, so that's 6. And then I have an x times an x, so that would be x squared. And then 2x times 4, I simply multiply the 4 and the 2, and that gives me 8, and I keep the x. I just bring down the negative 7x, it hasn't changed yet. And from here, I would just combine any like terms. My like terms are the 8x and the negative 7x, so that makes 6x squared. 8 minus 7 is just 1. So plus x or plus 1x. Either way, you get the same answer. That's the more common way to use a distributive property. Again, do take note, when you multiply x times x, you get x squared, which is a common mistake that people will forget from time to time. Another way to apply the distributive property is in these two different methods. You may have heard the acronym FOIL, which stands for first, outer, inner, last. Whenever you have two parentheses multiplied together, it's important that each term gets multiplied to every other term. So if I have 3x, I will multiply it by 2x. And this 3x will also get multiplied by the 4. So 3x times 2x. Multiply the 3 and the 2, so I get 6. And x times x is x squared. And 3x times positive 4, well, that's just 4 times 3, which is 12x. Now I'm done with the 3x. Now I'll multiply the negative 1 to both the 2x and the 4. So negative 1 times 2x would just be negative 2x. And then negative 1 times 4 is just negative 4. Now, just like before, I want to combine any like terms. Once again, 12x and 6x squared, those are not like terms. The only like terms you have are these two, the 12x and the negative 2x. 12x and negative 2x make positive 10x. And that's your answer. This problem here is a very commonly missed problem. A lot of times people just try to square everything and say that your answer is 4x squared plus 1, which is incorrect. When you have a quantity squared, that means that you are multiplying 2x minus 1 times 2x minus 1. It's a foiling problem. So, just like how we did the previous example, I will multiply 2x times 2x. So 2 times 2 is 4, and x times x is x squared. And then I'll multiply 2 times negative 1, 2x times negative 1. That's a negative 2x. Now I'll do the inners. So negative 1 times 2x, so it's negative 2x. And then negative 1 times negative 1 is a positive 1. And finally, just like before, I combine my like terms. Negative 2x and negative 2x is negative 4x. The 1 and the 4x squared didn't change because there weren't any like terms to go with it. And that takes care of our polynomial properties portion of our honors geometry summer packet.